This video is going to take you through the Explore It activity for Unit 1, Lesson 2. And pretty much what this activity is asking you to do is to play around in some graphing technology. So you'll see that I have Desmos pulled up on my screen here, just to play around and see what changing numbers out does to the graphs of particular functions. So essentially what we're going to do here is play with the numbers. So they have asked us to use the parent function y is equal to the absolute value of x. And when I've taught this in previous years, I have started with this because the transformations are particularly easy to see with absolute value functions. They're just easier for us to see what's happening. Sometimes with other functions, it's just a little bit harder to see. So that is our parent graph. I'm going to leave that up there because when we start playing around with it, it just helps to be able to see where we started from. So remember, absolute value graphs are V-shaped. They have a vertex at the origin, and the slope is 1 and -1. So the first part of this activity is asking us to use different values of k to add k to the end of the function. So I'll start with k equals 1. And what you can see there is that when I put in k equals 1, that the graph goes up 1 unit. And so if I go back and delete the 1 and make it a 2, it goes up 2 units. If I add 3, it goes up 3. And we could do this, so I was for the 5 in there. We could do this by building a table, but obviously it's much faster and more efficient to use graphing technology to do this, and we get the point. We get how that number is affecting the graph. Now we want to make sure that we're using positive and negative values. So let's say I add -2. Okay, and so you can keep that with the plus negative. For most of us, instead of writing plus -2, we would write -2. That is exactly the same thing. So if I add -2 or subtract 2, I am sliding the graph down. And just to make sure that that holds true, we'll try -3. And I think I mentioned this in a previous video, but the easiest place to look at is that vertex. So that's just the easiest point to track rather than tracking this point over here and seeing that that point went down 3 units. It's just easier to reference it from that vertex. And we'll do one more. Let's do 1.5. Look at that. Why restrict ourselves to integers? What's really neat about Desmos, though, is when you hover over one of those points, the coordinates will pop up, so you can see exactly where you're at. So the conclusion that we want to draw there is that adding or subtracting, adding positive, negative numbers outside of the absolute value slides the graph up and down. That's our vertical translations. The next thing they ask us to do is to add or subtract numbers inside the absolute values. So I'm going to go ahead and we'll add 2. And again, trace that vertex. And by adding 2, you will notice that I have slid it to the left, which is probably not what you were expecting to see. Ooh, adding it made it go left. Will that hold true? What if I add 4? Okay, and we could add 10 and we can slide it all the way down to the 10. What if I, now I think the way that I copied it down off of it, they have a minus sign in the formula. So this gets it kind of messes with people with the signs here, but so instead of adding, let's try subtracting. So let's try subtracting 3, and subtracting a 3 makes it go to the right, and probably that will hold true. Make it go all the way over. So one of the ways that they encourage you to think about it is think about the minus sign being in the formula. So in this case, the minus sign is part of the formula. You guys can't see my hands moving, but they are. So the minus sign is part of the formula. So if I subtract a positive, it will go to the right. It'll go in the positive direction. If I subtract a negative, it will go to the left. And so if you think about it that way, you're subtracting a negative. Now it seems like it matches up a little bit better. So you got like the -3 over there and you see the -3. But most of us do not use that kind of notation where we're subtracting a negative. It's just too many negatives for us. And so to subtract means to add the opposite. So subtracting a negative is the same as adding. And you can really see that. So like subtracting a -3 does whoops, hold on. Does exactly, wait, what happened? Hang on. There we go. It does exactly the same thing as adding 3. So that is probably the most common mistake that students every single year will make with the transformations, is that the left and the right are backwards opposite from what you're expecting them to be. So adding a 3 makes it go to the left, and subtracting a 3 makes it go to the right. But if you think about the subtraction as being part of the formula, so you're subtracting +3, okay, like now it makes a little bit more sense. Okay, +3 goes to the right, subtracting -3 and it goes to the left. So hopefully that cleared a little bit of that up. It does take some practice, so be patient with yourself if you tend to get the left and right backwards for a little bit. Just keep working on it. Whenever you get it wrong, make the correction, just reinforce like, oh, that's right, that left and right has that backwards thing. And eventually it will stick in your head. Eventually it'll make more sense to you, and you'll stop making that mistake. But just be patient with yourself. Rewind this part of the video, open up Desmos, play around with it yourself for a little bit, and just kind of handle the information in the material, and eventually it'll stick. The next one they want us to do is multiplying a number out front. So we're multiplying the absolute value. So let's go ahead and we'll multiply it by 2. Okay. And what you might notice, there's a lot of different ways that people will describe this. Usually students will say it's skinny. The correct term is vertical stretch. Okay, because you're pulling it vertically. Other students will notice sometimes that the slope has changed. So instead of having that slope of 1, you now have a slope of 2 and -2, which should not surprise you there. Let's go ahead and do the 3. Now let's make the number. We want to try different numbers, like what happens if the number is less than 1, because right now there's a 1. So if I put a 1 over there, you can assume there's a 1. So 1 is the number that's there. If I go higher than 1, I am stretching it. If I go less than 1, all right, we have a vertical compression. So it's like you're pushing that absolute value, compressing and pushing it down towards the x-axis. And you might notice that the slope is now 1/2. We have rise over run. Oops. And so when I get up there, I'm gonna there we go. Though it has gone up 1 and right 2. So the slope is 1/2. We'll put in we'll do 0.1, okay? And there is like the slope is 1/10. So I go up 1 and over 10. Now they also want to make sure that we consider what happens if we pick a negative number to multiply by. So I'm going to go, I'll keep the 1/10 there, and all I'm going to do is put the negative in front. And what that did was it reflected it over the x-axis. So the negative actually does not change whether it's stretched or compressed. The negative is a different transformation. The negative controls whether or not it's reflected over the x-axis. So we could try another one. Let's go ahead and put like the 2 back in there. Okay, so we know that the 2 controls a vertical stretch. If I go and make that 2 negative, I have now reflected it over the x-axis. So this is usually how a lot of us will describe it. We just have to be careful about the absolute value of the number that you're multiplying by. Okay, the negative has a different transformation to it than the actual value of the number. So just kind of keep that in mind. So this one has a reflection and also a vertical stretch. So you actually have two transformations going on there. And then the last one they want us to play around with is putting a number inside here. Okay, so let's go ahead and put a 2 on the inside. And it looks like it did exactly the same thing. Now, it's actually not, or it obviously is. Like if you have watched the lesson or you've kind of interrupted the lesson to detour over here to watch this demonstration for the Explore It, then you haven't gotten there yet. But this actually is also a stretch and a compression, but everything is like flipped around, and it's also not very common. So well, let's like play around with it some more. Let's do a number less than 1. Okay. Now let's make it negative. Okay. So when we did this before, it actually like flipped it over. And you will notice now we do not have that reflection. Now that is because where we put the negative was inside the absolute value, and we know that absolute value is distance from 0, and so there's no such thing as a negative like result from an absolute value. There actually is a transformation that happened there, but we can't see it. Because of the natural symmetry of the graph. So playing around inside the absolute value is different from like playing around and multiplying stuff outside. We just can't see like all of it right now. I'm gonna try, no, you know what? I don't want to muddy the waters too much. So that should hopefully help you get the point of that Explore It. Again, the idea is to play around in Desmos and to get like really comfortable with this, because if you are struggling with a homework problem or with some concept with a transformation, one of the strategies and tools that you have available to you is to hop on over to Desmos and take a look at it, like see what the behavior of the graph is. You can use this utility to check your work or to give you a hint or a clue for how to move forward. So hopefully this video did help you with the Explore It for Unit 1, Lesson 2.